So I'm Alex Chang. I'm a chemistry major with a math minor here at Cal Poly, and my intended career is to actually teach high school math. It was definitely different because, like, again, I'm a chem major, so most of the classes are pretty, teacher at the front and then students back, sitting in the stands, basically. So this one was definitely different, and it really gave, the students a chance to, it really gave us a chance to show what we know and, what we think. It gave us a chance to think, essentially, instead of just absorbing what's being thrown at us from the board. The way that the class was run was a lot of student presentation. So there was, of course, a little bit of lesson time planned in, but a lot of it was students presenting their solutions to different book problems. The way that the book was set up was, it's a very interesting book, actually, is that there was no, here's a definition of something. Well, there's definitions, but there's no, this is what this is. It was really, use what you know before just to expand on this theorem, which I guess if you had taken geometry before, you would kind of know that it's true, but this class really asks you to show that it's true based on what what we're given beforehand. And so the way that the class was run was, if you didn't present, if no one wanted to volunteer to present the solution, then we didn't see the solution. So it kind of forced you to, but it was really cool because no one, obviously there's some people, there's a little bit of stage fright. Obviously no one really is super comfortable with presenting. Some people are, but it was pretty easy to get us up into the front of the classroom and sharing our work. And it was totally open to criticism, but obviously helpful criticism. And everyone was just comfortable. It was really nice. It was definitely, the group work helped in just giving you different ways to approach different problems, essentially. So everyone, most of the class was in groups if we weren't already presenting. And they just gave us time to explore different avenues of how to get from here to here, basically. I definitely am starting to think more about why do we know what we know, essentially. So I was I'll take my chemistry courses that I started taking after that. There was, you could imagine that there's a lot of information that gets thrown at you, and I really try to take the time now to wonder why is that what it is, basically. So it really helps me answer questions and not really be afraid to ask questions. And just is generating more curiosity about essentially why we do what we do in really any subject like biology or physics even, or yeah. The way that IBL is run, I think as a student, I thought that was just way more fun. So I've been thinking, well, if I want to be a good teacher, I think it helps to teach something if the students are enjoying it, or at least find it interesting or useful. So that's basically what my focus has been, is just trying to make the calculus that I'm trying to get my students to help understand, that the calculus is actually useful and is actually, well, if it's not interesting, then at least useful. So yeah, definitely something the aspect that there's not one way to teach has been really fascinating to me, and I've kind of been trying to pick up on things like that. Different ways, how can I do better? And there's no end goal, I feel. If you're, not to take away anything from going into industry or something with chemistry, but the teaching job, I feel is always evolving, right? I can always do better, or there's always another kind of student or something like that. I want to at least garner some kind of interest in the subject in everyone, and using kind of an IBL approach. Obviously, I'm not trained or anything in it, but I always ask them for their contributions. I try to work problems myself in front of them as little as possible, and I always want to see what are they thinking, if they get stuck, well, what have you tried, things like that. I think if anything, it's the thought process that matters, right? So even for just an example, if I don't care if they can't understand a calculation of something, we're talking about, say, two vectors and doing the cross product or something. If they can at least understand what does the cross product mean, then I think that's kind of a more important step than how do I actually do all this calculation. So a cross product, A cross B is a new vector. So that's one thing, is that it's a vector multiplication that gives you a new vector, not a number. And then, what does that vector look like geometrically? Well, that third vector is perpendicular to the first two. Those basic understanding, those crucial, fundamental just ideas, I think is That's like what I really care about. And obviously, like and the calculation is something that you can memorize, so I don't really try to focus on that too much. I really try to get them to understand like the concepts. The inquiry-based learning style, I think, has really driven home the idea that is what's important, because otherwise we're just like memorizing equations and calculations and things like that. And again, just like as a student, I think that's really boring. And if I get like, why am I in school if I just need to know how to do a calculation? I could get that off the internet or something. Yeah, so I always, again, going back to just like, why am I learning this, like in whatever class I'm taking? I always try to think back to, I mean, I guess sometimes it's hard if you're not an expert in the subject, but how does this relate to like real life? Things like that, basically. So it does, just because you're curious, it does lead you to do a little bit of more investigation on your own, even if it is just like a quick Google search, like, why does this matter? or examples in real life of this. Obviously, like them trying to share ideas is important. Also, in terms of like projects, I would try to basically frame projects around why subjects are important. So like, say, if I'm teaching like calculus, well, if I wanted to like maybe you're going to design a roller coaster or something, so you wanted to see how fast your roller coaster is going down this certain, peak in your roller coaster or something like that. Like things that are actually interesting and make my students see how this is actually implemented in real life.